Hello guys. I'm just gonna set up this stream here. Welcome to the stream if you're watching this in the future. Today my goal is to set up some stuff here for the level editor, and hopefully we will be done today. I know that I said during yesterday's stream that I would be back, but yeah, I ended up doing a lot of different stuff instead that he needed doing. Yeah, that had to have priority instead. But since I think we made so much progress yesterday, we should probably be all right. Hopefully I'll be done with the level editor today, or at least the basic functionality of it, because um, there would be a lot of different features that you could add to a level editor. Um, you need different tools in order to actually, what do you call it? You need different tools to sort of handle a lot of different stuff in a level editor. So it's basically the basic parts of the level editor. Okay, so we should probably compile some stuff that needs doing. Uh, I know this will be a bit messy. Uh, I think we have most of the functionality, at least for static objects. So let's just delete that to do not today, to do future, uh, add functionality to handle dynamic objects, and maybe even transient objects. Um, add object picking for, well, maybe today add object picking for OBBs and spheres. Uh, future improvements. Um, end raycasts on object picking on far plane of projection. Of view frustum projection. Let's see, maybe we want to do texture scaling. Probably we want to do bounding volumes. Yeah. We will do this in the future. We will do a save, simple version, uh, or rather, uh, loading, simple version. This will be maybe, this will definitely be today, because let's see, is this sorted correctly? Let's see, this is probably something more that, like something we would want to do today. Also, maybe we want to do this today. There we go. So this is cleaned up a bit. Fix text field bugs. That is the primary objectives of today. Also, I optimized the way the renderer passes the UI information here. In terms of this gizmo thingy, we would need to be able to render both, what are they called in English? I think it's called trapezoids. Let's see. Or parallelogram. Yeah. Parallel. Oh, grams, I think. Or maybe just. Well, let's see in Blender, for instance, how are the gizmos drawn? Well, we do have some line that is basically a box. Then we have a rectangle that in 2D space is some sort of parallelogram, I think. Yeah, so we want some sort of parallelogram, uh, and circle rendering. Parallelograms and circles. We could change our UI in such a way that, well, we simply created some stuff here in terms of how to draw that inside our UI shader. Right now we only support rectangles. Triangles. Yeah, we would need to be able to render that. Otherwise, we wouldn't be able to create a gizmo. Yeah, right now. Well, we could submit it to our renderer during this step, depending on how we would like to do it. We would probably need another field. Yeah. We could also just let the GPU handle some logic inside this shader, meaning that for rectangular UI elements like this, we would do the one thing, and then for other stuff we would do other things. Yeah. Yeah. We could also just do maybe a bit of line drawing. We could cast some rays, draw some rays in 2D space. Well, that's different. There are different options. Yeah, I should probably contemplate what is optimal in terms of doing that. Anyway, we're not at that state yet. So I'll decide on that later on, because this is just a rectangular pipeline, which is quite alright, but yeah. So right now we have a scope for today. Let's see. We will look into the UI situation here. Let's see. What did I? Yeah, so to do support text fields, I'm not sure this bug is actually present anymore for some reason. Let's see. What if I choose an object here and let me delete something? Well, it doesn't jump up and down anymore. Maybe it got fixed after I reset the handle stuff. Yeah, so far I can't seem to affect it. Anyway, also to do future, make a selection texture that gets blended with the base, the current texture of the selected model. We could do that, or we could do, that's one option, make we could do an upscale, downscaled version. It easier to see texture and material on object selected. Uh, that's solution A. B, create a copy of the model object, which is scaled by IE 1.1, and then transparent. We could also do that. With a selection texture applied to it. But we will probably get into C buffering problems or depth buffering problems. Yeah, so I'm more like doing this maybe on a compute shader. So we could do it asynchronously, and yeah, that would also be a cool project to do. Some pixel-based stuff. Yeah, that could be cool. Yeah. All right. I'm pretty sure I'm supposed to just add this to the possibilities for the future. Um, yeah, since I probably should focus on fixing the rest of the level editor today. I mean, I can always do improvements. Yeah, there's always functionality to add. I mean, I mean, this would be a great quality of life improvement. These are like these are like um, more game world specific. I mean, levels should mostly, at least for now, consist of static objects, meaning that um, let's try to prioritize this in order. I think this is actually pretty significant because you can't see anything. And this is just further functionality in terms of designing levels, which is definitely needed, don't get me wrong, but it's like expanding the functionality of the whole tool itself. With this done, we could create simple levels designed on static objects that would have bounding volumes that we could save and load from file, um, that we could potentially um, yeah, okay, let's do texture, uh, transform, editing. Yeah, so in a prioritized order, I think this is needed for basic functionality. This is definitely a high priority issues, or what do we call them? High priority work, since it will make the workflow of the tool way easier and extend with um, what we really need. Yeah. So if we group it like to do future, this is probably the roadmap for this. Mm, let's see, let's add this to this area here. Okay, I think I've been contemplating for long enough what to do. I mean, at least it seems necessary to get a mental map of all the ideas and to kind of limit the scope of what I'm trying to do. All right. We should probably get working then. At least that's why we're here, right? Mm, yeah. So, I don't think the scroll thing is problematic anymore. It might have been in relation to some other problem. Uh, I would like a checkbox thingy. Mm, yeah. Basically, when you have a system this complex, um, you end up in a situation where there's always something you could do. And I have to remember the focus of the series, and it is implementations that result in as much progress and um, what do you call it, workflow optimization or whatever. Um, uh, I should restate that. I mean, the goal of this series is to implement something where we actually implement something instead of just improving features endlessly until we have a perfect tool set or system. Um, that would be derailing the whole purpose of this series because I want to get to a working prototype. So this is problematic though. We need to fix the text fields here. Um, I was wondering whether I just could hard code the size of the text fields um, at least temporarily because I want to be able to see what I'm actually doing. So if I hard code this like 4, will I get a crash or a problem? Whoops, that's the mesh, of course. Well, that didn't really change anything. Let's see. Let's go to the thing here. If we change this to something like 4 characters, does our value here then override the control size? It does, doesn't it? Yeah, and we don't have cursor problems, at least from what I see. Let's see if we override them for all our controls here, because I think it makes it easier to see what's actually going on. We might even want this as a standard way of drawing the controls. Did they get bigger? Let's compare to down below. No, I'm not sure they got any bigger because we probably calculate the sizes here. Amount of visible characters, if it's bigger. Otherwise, we actually use the text size, so it needs to be bigger. Let's see, if I change this to 3, we should be overriding that. Yeah, okay. Let's see, did we mess up the editing? No, that still works. Okay, let's decrease the let's see. Let's see our font sizes here. For instance, is hard-coded. This is the one we're using. The size is 14 pixels. Line height, base, width 14. Well, the average width of the characters are probably okay, for now we will edit it manually. Let's see, font size. So it definitely got a bit better. Yeah, we will manually force that for now. I mean, yeah, okay. Next thing we want to do is, of course, add this version here. Yeah, maybe we want this as a standard for all these controls because they can end up being too small and you can't see what you're really doing, and yeah. Whoops. There we go. Okay, so our controls are now bigger. Huh? Oh, it's because we don't reset the buffer on the change itself. Let's see. Um, yeah, so that's a bug. We copy that. This is our cursor manipulation. Mm. And then reset here. Maybe. Ah, no, that's the pointer. Let's see if we do like this. This dereferenced. Oh, it's because it's const. But let's see, maybe we can do memset our text buffer here. Value 0. Let's just cast as a void pointer. We don't care about that. Size of char times 4. We simply reset the first part of the buffer. We could do that at least. Let's see, so Okay, that's only something that happens. Okay. Okay, on this, we would like to reset it, I think. Whenever we release the handle, no? Okay. Let's see. Did we put in a global somewhere? Yeah. Nope. All right. Let's do a check up here. I think we need to do that. So if the use internal, so we use the internal buffer. We are computing new handles, so it shouldn't be firing on the same handle. We copy the contents. All right, so we have a problem when let's just do a print of this contents here. Internal buffer contents, and we will p context text field data dot text buffer here. We will write out the contents of that. It copies only the first part. That is why it overwrites only the first part. Plus we could add the simply copy whatever our text buffer is allowed to contain. Let's see, 0, 1. All right, that was the problem. We simply copied too few bytes. Yeah. Let's see if I disable the output thingy that we're doing. Like 100 times a frame. Do we still have drops in frames related to that are massive? Well, we should only do it the first time, I think. So it shouldn't be that heavy on performance. I mean, let's see, let's just print out whenever we're in this state, in state. Hello, how are you doing? Why are you crying? Yeah, we only happen to be in that state once, so it shouldn't be that performance heavy. Okay, we reset the buffers. Let's see. Maybe we fixed some issues then. We might have fixed some issues. Not all of them, of course, but right. Something may relate to the period logic here. Let's see. Yeah, we replace whatever we see, but it doesn't stick with us. Okay. Okay, we overwrite. Okay. So basically, yeah, so what we want to do is to compile a buffer. Let's compile a buffer, a temporary buffer. On the stack, I think. Hello, buddy. How you doing? VK back, right. Oh, that would be nice. What are you gonna study for? Let's see. Any particular test? Let's see. Oh, okay. Well, good luck. Okay, we will do. So this is. I'm not sure I have that awesome of a voice, but thank you. It's also nice to have you here. So, but feel free to mute me if you need to. So in general, maybe we should compile this into a series of yeah, this also needs to break because we don't want to okay, these are controlled. So for our input processing here, these are our legit characters. Let's see, minus virtual key win32. Let's see, 1, 2, numeric, add, multiply, divide, subtract. Okay. So if we kind of like right now we will disable all the logic of this. So if we get a key in the queue, that is a okay. Let's start checking for the key is pressed and then breaking out of the loop here, meaning that we don't need to process anything after return. Then if we have a key q pointer, which is equal to the subtract, we of course need to add some handling for the subtract and the period here. Okay, so these are the characters that we will accept. If we get any of these, we will pass them. Let's just move this, whoops, and let's comment out this because we will handle that internally. So if we ever press the backspace, we kind of like merge the two parts. And we do the same thing with the left and right key. So these are basic controls over our text field. Okay. So sorry, I had a sneeze. I wasn't able to mute in time. Okay, so let's do a switch on the key itself. Let's do a default that we will use for whatever, and then we will do case subtract and case period, because these are kind of like special cases that we want to handle differently. Okay. So the idea is we want to add our character. Let's see. Char symbol will be 0 per default. In this case, we will set our subtract symbol here. And in this case, we will do like this. We will add the period. Otherwise, we will set our symbol to our key here. But yeah, as you can see, we might end up adding other symbols. Whoops. There we go. So we could add more. We will create a char temp buffer with the size of our, what do you call it? Hello, man. How you doing? Let's see. So down here or maybe up here. Yeah. Are you dead? That can't be true. Unless you're a ghost. So we create a small buffer here. And we will have our please. I'm this close to moderating you. Yeah. No. I can't say I do that. Do you? So our cursor. Uh, well, I guess it depends on what your skill sets are and what you're trying to do. I mean, web development isn't that complicated, at least usually, depending on what systems you try to do. Okay, so we want the let's see if our cursor here is actually having a value. Otherwise, we will just do something like this. Thank you very much. God bless you too. Okay, so if we actually have a cursor set, meaning that it's non-zero, we do one thing. Otherwise, we simply it must be 0. So therefore, we're at the first position. Then we should simply move our text buffer here. And we will cast it to a void pointer. And we will cast this to a byte pointer. Whoops, this is the source. So, and this is, let's see, 0 here. Okay. This is the destination, or rather the destination, yeah. Byte pointer +1. And then we will do whatever here. And then we will set the text buffer 0 coordinate. Oh, it's not modifiable. Let's see, char pointer. Let's see, dereference this. First we cast it to a char pointer, then we dereference it. I think okay. Static cast char pointer. Okay. Well, we have the problem that this is a const char pointer. Maybe we just want a char pointer instead. Let's see how much of our code breaks if we do that. Let's see, creation data, text field data, char pointer. Nothing breaks. It doesn't make sense that we can't change the content actually. So we will set our first slot here afterwards as our symbol. All right. Let's see if we are ever at the first position of the text field. We should be able to add values. Well, it doesn't really work as intended. I mean, well, that worked. But what happened in terms of 999? Well, we also, of course, have to update the buffer size plus plus. This will simply make it overflow. Let's see, do we set any other fields? The cursor shouldn't change. Okay. So let's see. And we can now add our values here. Great stuff. Okay. We moved the floor and fell through it. Okay. Let's mem copy into the temporary here. destination temp buffer. Let's fill this out with our data here. Size of char times our cursor, meaning that hello, thank you. Then we set our temp buffer. We set our, let's see, so if our cursor is at the 1 position, meaning that it's not at the 0, we have skipped the first character. So we want to copy the first character. Then we want to set the temp buffer size. And this needs to also be less than this, because maybe even I mean, yeah, so if we are at the 99th position, we simply want to push out the last part of the buffer, if it's even there. But let's see, let's set the symbol here. And then we can do an if check if our cursor position dot +1 is lower than this. It means that we have something that we need to add. So instead of using the intermediary, we will simply be updating the underlying buffer directly here. So if we're not at the last position, we want to memcopy to our let's see, is this logic correct? So if we are, for instance, at cursor position 1, that means that we will copy from our text buffer the first character into our temporary buffer. Then we will set our second character to a symbol. Then if we're not at the end, we will have the other side of the buffer to copy over. We will be at our second position. And which is one offset. But we have written to that, so our new starting point is our third offset. Okay, so our byte pointer, our context here, plus our cursor plus 2 will read from byte pointer this plus the cursor. And then we will copy for the following amount of characters minus the cursor -1. Okay. And then we will copy the first part. Let's see, p context text field data text buffer, and we will copy from our temp buffer, and we will copy size of chart times cursor +1. Otherwise, we will just copy this, which will be, because it's not low, it's not lower than, well, yeah, we will simply copy the whole temporary buffer. So this should hopefully work. Let's see. So, well, it doesn't. Okay. Let's see. Let's step into this function here. Let's see what we're dealing with. So I will type in a value. Let's see our temp buffer here. -2. Yeah, that seemed correct. Oh. We're skipping one. Let's see. Okay, let's try this. So I offset into here, I press a 4. Okay, it does get registered. Let's look up our context. Text field data, text buffer. -20 is the old contents. Well, so this doesn't work. This doesn't work. Let's see. So our buffer does get updated correctly. Our temp buffer here. Let's see, let's press that 4 again. So our temp buffer is fine. Temp buffer minus, yeah, so we need this last 0 on the other side. And let's see, p context, text field data, text buffer. Maybe +1 here. Let's see, because it didn't register the last value, which was actually added. So let's see our context here. Text buffer 24, so it overwrites the that is correct, isn't it? And let's see, temp buffer, yeah. So that is actually correct. And then it needs to splice the other stuff here. So yeah, the start of the buffer. We could just do something like string length of string length. I don't know how fast that is. We also know that it's plus cursor, maybe +1 here. And the source itself. Let's just do 10 here. Copy 10 temporarily. All right, let's see. What do we end up having? 240. So this one ends up overwriting. Okay, let me try again. Hello, buddy. So our temp buffer. So we wanted to add a 0, 240. Minus 240 should be the contents of our final buffer. I'm probably just calculating the... Yeah. Yeah. I can imagine it takes a bit getting used to. Okay. So right here, we aren't actually offsetting enough, I think. Or are we? No, maybe that's right. Actually, minus 240. That seems correct, doesn't it? Hmm. Let's do unsigned in current field length. Now let's just do minus the cursor -1. Let's see. Does this work then? Um, well, it doesn't really, does it? Mm, let's see. Print writing to position. Uh, written up to. So, well, of course, we need to also increase the buffer size here. Okay, it actually works as intended. So, okay. So that should mean that we can do something like rotate this. What? Huh? Maybe it was just there because I translate those fields. Minus 0. Maybe I did a -1 anyway. Let's see. 90. Well, this 0 gets. Ah, that's weird. No, it's not weird, is it? This is not weird. Okay. All right. We could also increase the cursor here automatically. Text field data cursor. So whenever we write a character, yeah, we jump straight after it, or at least we try to. It doesn't really update the field. Well, maybe we want to do it here as well. So whenever I write that, okay. Let's see what happens if I rotate something 90 degrees. Well, okay. Let's see. If I, okay, and I can enter 90 again. Okay, I can rotate this 90, I think. Yeah. All right, great stuff. Let's see. Let's enable the debug mode here. And as we can see, our bounding volumes rotate accordingly. Great stuff. So now we actually have a working level editor. At least in terms of editing object properties, uh, there are definitely some quality of life improvements that we need to do. Let's see. Yeah. Um, okay. One thing I would like inside our system here is MS CPU. Hello, OpenGL. Let's see. How you doing? All right, let's see. We can add a static object here. Yeah, probably, but it's not a high priority. And that's just details that really don't do anything in terms of usability. Let's see, 45 degrees here, 45 degrees here, and then a material. Now, isn't that beautiful? We can now create different objects here. Let's see. different objects like that. We can also scale it twice on the x-axis. Oh, whoops, that's the wrong object. Let's scale this. Yeah. Great stuff. Okay. Okay. Great stuff. Great stuff. So the UI got fixed. Oh, I forgot to test whether I can actually. I have actually haven't implemented any clipping on the elements, which means that, as you can see here, I need to be able to see an object before it gets rendered. Otherwise, it just gets clipped. The same thing goes for here. You could do something where you render partial objects that you can actually see, but yeah, I'm not gonna do that because it adds a bit of overhead to the UI computations, and I really don't need them. Uh, it's just like improving the graphics of the UI, and yeah, as I've mentioned, this is more like a UI that is. No, I don't use DirectX11, and I don't need a scissor rect. But anyway, uh, hello Ox29, how you doing? That's great to hear. Thank you very much. I think it has turned out pretty good so far. I'm really close to being done with the first part of the level editor here, um, with object picking and so forth. Um, yeah, and we can do object editing and so forth. Yeah, so one thing I would like, we fix the, oh, great. Have you done a game engine before? Uh, let's see. Uh, mm, let's edit this actually. Uh, yeah, I think actually that is the way to do it. Uh, trying to design something that you have no um, idea of the overall design will probably be very, very tricky. Not that I'm saying that you won't have an idea, but I mean, there are so many systems. Hello, buddy. There are so many systems that need to interact, and it can turn out to being too abstract. Doing, I'm working on. I is probably gonna stay the same, I think, because that increment function returns the value before incrementing it. So it will just stay the same as far as I know. If you swapped the plus plus to the other side, it would be ever increasing, I think. At least in C++. Ox29, I'm working on my game prototype here, and I've built a level editor with a UI here. Whoops. I don't know what happened there. There's some kind of a glitch. I've never tried that before. Maybe it's during the computation of the camera stuff. Let's see. Well, okay. I think it's during the computation of the view projection, view matrix for the camera. But yeah, I've built a UI and some object picking and some object manipulation algorithm where I can rotate stuff. Um, I've created bounding volumes for physics. Yeah, uh, we do have physics actually. Let's see if we exit editor mode here and move towards our Paul here. As you can see, he doesn't want to be stuck in a wall when I enable the simulation. I can do force manipulation of Paul. We have a player that is bound by a sphere and a collider. You can also jump, do weird stuff. So yeah, I'm just finishing up the basic functionality of the level editor, where we will do a bit of saving and potentially a bit of loading. Well, um, I've yeah, I thought I had that one. So, but you could probably ask me similar questions in different programming languages, and I wouldn't know. And OpenGL, that's really a silly programmer joke. Anyway, I really need a bathroom break, so I'll be back in 10 minutes where we will try to do the saving and loading algorithm, at least a simple version of it. And then we will decide on what to do next. But I'll be right back. Let's see. Is this the one? Oh, the panels here in OBS are messing with me. Whoops. Just a sec. All right, be right back. All right. Let's see. Why does the chat reset? Oh, I probably told it to. Let's see. Refresh browser when scene becomes active. Well, I guess that's nice, but I have to reset it every time. Okay. All right, all right, all right. So I imagine the saving system being some kind of line parsing system. Um, yeah, I was missing you guys too much. Couldn't stay away for longer. So in general, I think we should do something like a line parser of some sort. Um, let's see, we have a load level that doesn't really do anything. We want a save level thingy here that we can call. We would also like a UI button for it. Let's see. One thing we would like also in the future here is to increase resolution of screen so that we can have some panels on each side. Yeah, we will toy around with that in the future. Anyway, let's see. Save level. Let's do save level. Well, I think if you just do like I equals plus plus I, like this, you would get that result. It probably creates a temporary in that instance. Let's do a test here. Saved level. Okay, so in Win32, we need something like save path dialog. Um, uh, okay, let's try calling this function. Do we need? Okay, we want a open file name struct here. File name. Let's see. Okay, so it has a lot of different settings here. Let's pass in the file name here. Is it a pointer? Yeah, probably is. If this, otherwise we fail to save level. There we go. Okay, let's see what happens if we press our button. Save level. Failed to save. Okay. Just instantly. Okay. Common item dialog. So I'm using something deprecated. Okay. Uh, mm, let's see. Can I get something like Windows 10? Uh, okay, what does this? Huh. Mm, iFile save dialog. Is that something? iFile save dialog. No. Oh my god, this is convoluted. Um, Open file dialog C++. Wait 32. We create a window probably. Don't we? Oh, this old API here is so convoluted. Okay. I think you can use GLFW, which basically is an abstraction over whatever platform you're working on. So you compile for Linux. It uses whatever API is needed for Linux and hides it all behind an abstraction. Yeah, but it seems like I just need to fill out some stuff here. We can maybe reinitialize this as 0. It's so weird that we have to specify. Oh, it's because it's C compatible. That should already be set to no. Fine. I should rename this. Long pointer, string filter. Do field 1. And we want a char file name actually 64. Data. Data long pointer to the file. Is it that one? Yeah, it's the file. File name here. What is max path? Okay. I don't know what that actually does. Max path. And string file. Long pointer string file. Wide string. There we go. Da-da. Da-da-da. Long pointer, string, title, file title, is that it? Great box, man. Let's do that. That's the title. Data flags must exist. And don't add to recent. Well, that's a fine little flag to have. Okay, let's see what happens. Wow, it worked. It actually worked. Okay, field 1. And we have the title Great Boxman. Oh, isn't that beautiful? Hello, Victor's Game Venture. Okay, do we have any settings that we can mess around with? Let's see. Open file name, structure, the struct size. Well, I'm guessing that you might have different implementations of this depending on your build system, so it needs that flag set. Okay. Filter strings. Okay, so you could do some parsing there. Let's see, do we have a field that is custom filter? File path or something. Initial directory. There we go. Let's see. So we should set some kind of path here. Long pointer. Whoops. Long pointer. Initial directory equals L. Well, let's do some levels here. Okay. Let's try that. Well, that didn't work. maybe I need to add some double slashes to this. Maybe. Yeah, there we go. Okay. And let's see what this guy say. Let's do any file here. And we simply add this. Wait a minute. Okay. Okay, let's use the text macro then. T instead. Maybe. Oh, wait a minute. It's because it's this is the problem. We need to change this. Can I not change the file actually? It depends on the version of it. I'm thinking. Do I have? Yeah, I do have a W version. Yeah. Okay. Any file. .html. Okay. It did save it. Yeah. For some reason, I had a weird crash. But anyway, it did get the file path correct, at least. Um, I don't know why. Stack-based buffer overrun. Is this overrun? No, it's not, right? That's not it. Well, that worked. Let's see. That also worked. So maybe maybe it was the buffer overflow. That was the problem. I was like, nah, it's not going to be that. But it turned out it was. It turned out it was. Okay. Let's do a. Let's see. So, okay. After the last zero, uh, level file. /0 dot level. There we go. Level file test. And it should automatically add that suffix. Uh, uh, file title. Can't we just create some automated stuff that automatically figures out the what do you call it? Okay. Uh, okay, so we could actually pass the filter, I think. Okay. Okay, so we can ask the struct here, which filter index um, did we use? Let's see. wchrt extension, which will have a 2D array. Let's just do 2. And we can ask our data, what did we get? Filter index and filter index afterwards. Let's see, extension 0 equals to maybe just no. Level file. Huh. Huh. Hmm. Uh, well, this is not as nice as I thought it would be. Mm, we can just do something like this. Instead, extension if filter index equals 1. Whoops. We set extension to level file. Must be a modifiable L value. Mm, okay. Uh, okay, let's just do a stupid mem copy. Extension, extension, size off. Let's see, wide string length. Uh, string. Is it this one? Okay. Dot level file. Let's see. Dot level file. Okay, so that's. Oh, we're gonna add extensions. extension. Oops. Ah, it's not happy with me. Yeah, I have to do the mem copy if I decide to do it. Whatever. Whatever. We could also do a new or a something like that, but yeah. Let's revert back to our old stuff here. Whoops. Let's copy this. There we go. It's a bit janky, but oh well, it doesn't work. Uh, I'm just messing around with the stuff here. This will work. Hello, Yasim. Yeah. Okay. I was not realizing what you asked. Yeah, data is a open file name struct from the Win32 API. Let's see. All right. For some reason, it seems to write a whoops, garbage value. Yeah, it writes a garbage value with this mem copy here. Ah. I'm not sure it did it before. Did it? that's definitely not enough. Mm. For some reason, the whole thing. Maybe I should need it. Oh, maybe I should just initialize it as 0. It's probably because I didn't do that. Then it's filled with garbage values. Yeah, there we go. It didn't have a 0 memory thingy because we're doing it on this stack here as well. Anyway, okay. So now we can actually force a sort of level to our file name here. If we actually use the level format, I mean the dialog box here is Great Box Man. That's a fine name for a save dialog, don't you think? Great Box Man. Or maybe you really shouldn't try to save stuff, just start over. A bit of motivational speaking from the dialogue itself. You really shouldn't try to save stuff, just start over. Don't you like it when your UI just gives you motivational speaking? All right. So now we have a file path. Um, the next thing we should do is simply just write to file. I'm thinking that the most simple implementation I can think of is something like, since we're only right now controlling um, static objects in our world here, we should do some for loops. Write data for static game objects, meaning they have the static flag on the bit field. Then we want to write data for each transform, write data for each texture transform, and write data for each AABB. Eventually, it should support a header with a save file version. Eventually, it should be in binary, I think. Texture transform is the transformation matrix that tells us how each texture is scaled on each object. So, for instance, in the game world here, this texture here on this wall is mapped to the wall. In reality, I only think the texture is something like this, and then it's just extended over the whole object. The same thing is done for these walls here. And you simply control how the texture is applied to the surface with the texture transform, as well as the UV coordinates of each vertex, of course. But the texture transform lets you rotate or scale or move or offset the textures on each object. So they have an individual texture transform. And AABB is simply the axis aligned bounding volumes that I can show you right here when I enable the debugging information. As you can see here, our guy here can't move through the wall because it has an axis aligned bounding volume that is not only a collider for the physics, but also what we actually do a collision detection with whenever we click. So yeah. So if we save the game objects with their material data, their texture data, and their mesh data, meaning simple IDs, and if we write our transforms for each object and each texture transform, and then our AABB, I think we would be able to write static objects in our scene to file. And no problem, man. And that would let us save simple scenes where um, it creates a series of static objects. There are limitations to the static objects since the bounding volumes are right now only AABBs, which means that we can rotate objects in our game world by any axis. For instance, let me show you here. We can do arbitrary rotations. For instance, rotate this 15 degrees on the y-axis, but that would mean that since the bounding volume is an AABB, it can't align to rotated axis. It will always be aligned with the coordinate system x, y, and z axis. So only whenever we uh, uh, rotate something by right angles do we get a proper bounding volume. The bounding volume is calculated for a aligned box by finding the minimum point in world space coordinates, which would be here, and then the maximum, which would be here. And then that is the entire volume. As you can see here, our body here can actually not move through the bounding volume, even though the wall itself is actually back here. So the bounding volume controls the collision detection, and also, as you can see, he can fall off this scene here. So this is a limitation. Of course, it should be extended to bounding spheres and OBBs, which are rotatable bounding volumes. Paul here, our test subject here. Let's see. Let me swap into the free floating camera here. So if I enable the debugging information and enable gameplay, you can see here that Paul is able to have his bounding volume rotate in 3D space, and it's also the volume that controls the physics. Yeah, he's slowly sliding off the wall. This is a bounding sphere. It's an approximation, so it's not an actual sphere, but you can be certain that each point on this icosahedron, I think it's called, which is a sphere approximation. Each point should be overlapping with the actual sphere, which is the underlying structure mathematically. Yeah, at least I think so. Okay. Or, yeah. So we especially want OBBs. And secondly, we want some spheres. Yeah, I think this is the overall plan for the save to file algorithm. Yeah, I want to make sure that our static objects in this scene actually does get created correctly during our current base level initialization. Yeah, right now we load the level and our game objects here. Static objects, we have static objects, but I haven't updated this part of the code to contain the flags. So object temp, object temp, yeah, flags equal to 1 bit shifted at the 0 spot. Let's see, and then it gets reset. So I suspect that every object now would be, we don't need the UI right now. I was working down here, or what? No, down here. Or, no, I was working on the save file up here. Okay. Let's just step into this function here in debug mode and see whether our flags are set for each static object. We do something like this, and we end up here. Okay, so the game objects themselves, we actually do place them in static objects as well. So the flag is set to 1. For a dynamic object, it should be set to 0. Yeah. So whenever we parse our data, we will see that the first bit in the bit field is set to 1, meaning that the object is static. Should we ever merge our object buffers, we can do parsing by using that. Okay. But since we actually only create and remove static objects, and since we have separate buffers for now, as you can see here, static bounding boxes and Now down here, static bounding boxes and dynamic ones. Let me see. Well, I think it depends on the scheduler, but the GPU pipeline is highly optimized for doing 4x4 matrix computations. Um, so it could be done in parallel. I don't know. It probably is single-threaded, but a highly optimized workload on that particular thread. I mean, everything on the GPU is aligned um, to suit the underlying architecture of the GPU, and I'm pretty sure that multiply operator maps onto some highly optimized multiplication method. Depending on your program, I don't know how it gets for one translated into assembly and two gets scheduled on the GPU. I mean, if you're trying to multiply two 4x4 matrices on the GPU, I think you would use the same thread for that so that things could stay in cache and be as fast as possible. My best guess would be that I don't know how CUDA works in details, but yeah, it's on the same thread, but with caches that are highly optimized to doing computations like that. I mean, matrix by matrix multiplication, especially 4x4 matrices, are um, such a um, essential thing of graphics computing. So yes, it can. I mean, do you mean a matrix of 100 by 100 matrix? I don't know OpenCL. I don't think there's any limitation on the matrix size, but I don't know. Matrix sizes. Uh, oh, I think you need to use some compute steps for that. I don't know what OpenCL is. Oh, yeah, okay, that's the compute pipeline of OpenGL. So yeah, I think you need compute steps for that. GLSL seems to be limited to graphics programming. That also makes sense since compute is like general purpose stuff, and GLSL graphics pipelines are usually for graphics only. Yeah, and also for it to be really fast, you would need to um, look into whether the matrix aligns with the underlying cache lines and um, what do you call it, memory of GPU operations. Otherwise, it would be really slow. Probably it would be faster to do a 128 times 128 matrix multiplication or something that aligns more properly with the underlying hardware, even though you probably have a few wasted cycles. You could parallelize it. I think you could chunk it and do um, yeah, GLSL and HLSL are just the programming language. So on a compute shader, you can invoke a lot of different threads. Usually the scheduler in terms of graphics shader programs, the scheduler on the GPU is in charge of whatever goes on. But if you do direct compute calls on the GPU, you can specify how many worker threads to assign to a different task, and you could do chunking and so forth. So um, yeah, you can do a lot of different adjustments, and it all is in GLSL or HLSL because it's just a programming language. But generally, when you talk about those terms, of course, you usually refer to graphics programming. But yeah, just use the compute pipeline. I don't know how the compute pipelines in OpenGL does assignments. Probably, or rather data structures. Probably you just do some custom data structure interpretation that is byte aligned. I mean, natively, the programming language supports 4x4 matrices, uh, but you can always just type out a struct that contains whatever data you need. The only problems you would run into is alignment. Hello, Linus Torvalds. Who is that dude? Linus Torvalds. Oh, the Linux guy. Yeah, I don't know how OpenGL works in that regard, but you would probably need something like that, especially if you want to parallelize it. But I'm pretty sure you can chunk matrix by matrix multiplications. I think there's some underlying algorithm pattern for it, but I can't. My hunch was that it was the Linux guy, but I'm really bad with names in general. I can't really. I'm not that great at remembering famous people. So how's it going, Fenbia? Right now I don't. I don't handle it. But I well, I changed my shader a bit. So I would do something like calculate the approximate line height and overall width, and manipulate stuff from that. Uh, I mean, yeah, if your line height is 10, so your font should have. Uh, I'm imagining that you're talking about fonts, right? So your font. Let me see. Let's just open this. So this font here has a line height and it has a base. The line height, of course, describes how many pixels the line itself can ever be in terms of pixels on the y-axis. And then the base determines on how far down the y-axis you need to be to find the actual base of the line. Yeah, yeah. Um, but yeah, use the line height and the base to calculate where the bottom position is compared to the top position of the text itself for all possible characters, and then offset that if you want vertical alignment to the center or bottom or top, and do that for each character. These two fields here allow you to compute the X and Y alignment, or rather, let me just correct myself here. Calculate the Y alignment. You can do that before you actually compute your string itself in terms of um, your rendering information. Um, you could do a quick pass of your font for the horizontal alignment, I guess. Otherwise, you would probably know some kind of you would probably know some information about how big is the rectangle that you're trying to align to. But yeah, then you would have to update your positions for the characters, for instance, afterwards. You could do a really quick pre-computation on how wide you expect the text field to be. So you simply just calculate the amount of X advance, and then you have the total width of your text field. And then before you process the actual positions of each glyph, you um, do some offsetting in terms of where is the midpoint of the underlying rectangle. Well, basically you don't need parameters. I mean, this is pseudocode, but you compute the y offset due to alignment and simply add that here to your Y position, and you compute the X offset due to alignment, and you would pre-calculate the total X offset characters. Yeah, you do. You need to specify both vertical and horizontal alignment if you're gonna work with both of those. But yeah, you could just do separate functions where you allow for alignment or not. I mean, computing the offset due to alignment is not going to be that computationally heavy, since it will just give you a value that you either subtract or add to the X and Y positions for each character. So once you have done the pre-computations of that offset, um, it's pretty fast. You could even, if you don't apply any alignment, just set it to 0. Oh, okay. Let's see. So yeah, this part of the work will be quite simple and not that interesting. We simply parse out to file this information here. Uh, and since I've been going at this for about 3 hours, and since I've started feeling a bit hungry, I should probably get myself something to eat. That's late. Yeah, I couldn't do that because I have work tomorrow very early. So all right, maybe I should do a break because yeah. Uh, no, I'm just gonna have a break. I'm starting to feel hungry. So I was contemplating just being AFK for maybe half an hour or something like that. Whoops, I opened the Twitch control panel here. Nobody, nobody. I'm just hungry, so I need to grab something to eat. I think, yeah, I think so. I'm just gonna probably just gonna leave this stream running. Let you guys hang out and chat. Excuse me. Let me see. Do I have a nice overlay here? Uh, I don't know. Are you live or? Let's see. AFK number 2. Okay, if I do. Um, oh well, maybe you need a refresh or something. Sometimes it lags behind the live session. Oh, that's the one. Yeah, yeah. Usually people who experience lag on the chatting aren't live. At least the guys on YouTube. I think YouTube sometimes ends up lagging a bit behind. I don't know. Okay. Let me see. Yeah, so if I change into this, uh, can you even read what's going on in the YouTube chat? I'm not sure. Let's see. Let me just adjust this a bit. Uh, Maybe that's a bit better for an AFK screen. I should really do a separate Twitch chat. Let's see. Maybe I can. Yeah. Let me try that out. Let's see. We will add another browser here. Twitch chat. I have to log in. Maybe if you visit the chat itself, or rather the stream itself. I might have an echo now. Let's see. How do I pop this chat? Uh, can't you stream a okay, let's see. Okay. Let's see. What happens if I do this? Okay. I'm just gonna mess around with this stuff here. Maybe I need to add it as a custom doc. Twitch. Maybe I can log in that way. God damn. Um, wait a minute. I can't use that anymore. There we go. I think we are on the right track here. I need to verify stuff. Oh my god. Okay, now I have Twitch chat on one part of the stream here. There we go. Let's remove this. All right. So now Twitch and YouTube can compete. Spamming. But we need to, of course, set the YouTube version here to live chat in order to be able to see any spam. Now, isn't that a neat little AFK screen? Yeah. And we could add a little live capture actually. I'm just playing around with stuff. Let's see. Game dump. Whoops. I'll of course jump back to this. I only meant to copy stuff here. Next I want to pass a reference here. Can I? Let's do something like, can't I change this? Yeah, I can. Okay, and if I do something like this, and I enter release mode here, I'm pretty sure. Oh, I'm almost a pro streamer. Oh, whoops. So if the game is running, whoops, it will get added to the AFK screen. Let's see. So if we make Paul jump and immediately go into, oh, whoops, that's not what I meant. If we make Paul here, let's see. If we make him jump, maybe we make him fall over just for fun here. Fall over first, and then, oh, okay, never mind. We will just let a collapsed Paul here be our screen. All right. Now I think my AFK screen here has been set up properly. Um, you guys should be able to entertain yourselves while I'm gone. Maybe we want the editor mode here. All right. I'll be back in a bit. You guys stay strong. I'll catch you later. Alright, guys. The old man is back. Let's see. Um, so we should probably get going in terms of saving something to file here. Yeah, you must be. Can you tell me, will I ever succeed making a game? Well, and since you're studying for a math test, I trust your instincts. That's pretty good odds, man. That's pretty good odds. Well, this makes me want to feel certain that I'm not haunted by a ghost, so maybe I should find someone who can help me if I'm haunted, or at least tell me if I'm not. I guess I can't do anything to alter my luck. Do you mean if I treat Paul nicely, my luck will go down? Do you mean that I should treat Paul nice or not? I'm unsure what you mean, buddy. Let's see. Level editor 0.2. Commit that. Okay, okay, okay. I'll try to. I'll try to treat him nicely then. Uh, yeah, I think I'm gonna. So yeah, yeah. Eventually I should. That is true. Okay, so it doesn't seem like there's a lot of penalty to doing stuff like that. Okay, let's create a private function here. Private uh void pass data to file uh wchar const wchar t pointer file path. Let's do something like that. Let's include the IOStream operator here. In unless I let's see. No. Oh, let's see. Um, OStream C++ header. It's inside the F stream, file stream, of course. Okay. we will create two functions here that are private as well. I'll get back to them. We will have a create poll function, and we will have a create player function. Since we don't want any levels without any poll or any player. But as I've mentioned, I'll implement these later. Let's see, this is our update step. We don't need to edit that right now. We want some save level data here. Let's see. Yeah, we could use DW string. Yeah, we could do that. Let's see. Let's do the OF stream. What does it take? Oh, it does take. Let's just do some lazy stuff here. Let's do stdw string file path equals our file name, and then maybe I can already do extension here. No, I can't. File name append. Whoops, file path append extension here. Let's return a bool here because we want to be not booling around in this scope here. Bad puns, bad puns. Okay. If parse data to file, else error wn error parsing to file name extension. Yeah, we could do that, but I think it's a bit time consuming. Let's see the OF stream here. Contact output stream, right? Open mode needs to be Let's see, file path. Return true. File path, extension, RC string. Okay, so we open our file path. Let's see, file, if file is open, we return false and print a message. Couldn't open file. Let's see, space mode, right? Well, usually it should be defaulted as out here. Okay, so we don't need to specify that. Let's just try running this for now. Save file 1, 2, 3, 4. Saved level. Okay. And it even created a 0 kilobyte file. Great stuff. Next, we do some file parsing. Well, first we create it, but yeah, the hard part is definitely loading it. It's pretty easy to output it because we simply output stuff like this, and then we close the stream. Header. Let's see. And we can parse files either C style or C++ style. This is a way of parsing that is C++ style. So leaving things in, what do you call it? In quotes are not great. What do I actually prefer? I mean, I like the way this syntax was because it's fairly easy to read. It's fairly easy to segment. I mean, Yeah, I really like this way of parsing the file, therefore we should indicate yeah, it's so much easier just to parse out the line itself. Yeah, I think we will do this kind of file loading at least based on the C API. And then, because I find this kind of, it's probably slow as well. It's probably slow. Let's see. So, okay, we will do something like header. First we will use Vim. No, no. I'm not gonna do that. I'm pretty fine with my good old trusted uh, good old trusted C plus Visual Studio here. Let's see. Let's do 0 points. How many zeros would we like for this version? 1. Let's do version equals this. Well, now it's self-explanatory. Why do you do that? Let's see. Oh, whoops. So the first field is our ID. File. Game objects. Format. ID. Let's see. Objects, mesh. Of course, we want to check here if the object flags only static objects. Uh, um, mesh material. Let's see. Bounding box. Bounding sphere. And flag, object flags. I was just about to suggest that someone use Google Chrome. All right, let's see. Level.level. Okay, it always adds the level extension to whatever file we end up seeing. Okay. That's definitely a bug. All right. So this is our file output. We simply parse out our data. It's not very efficient or anything, but it'll work, and we will probably change everything so many times that it won't be helpful to actually write a lot of solid code right now. Okay, let's see. What do we want to dub then? Excuse me, having hiccups. Transforms. All right, this should compile a list then. std unsigned int transform indexes in the see, in the indices, I think. Transform. We will do that, and actually we will constant sign int transforms trans index inside this, and then we will simply file transforms trans index. Maybe we don't want to type that all the time. We could just do something like object transform pointer. Position X. And let's copy this. Y and C. Pause X, Y, C. And then we want rotation X. You guys, it's like one of the silliest dares or challenges I've ever seen. Okay, if you really want to suffer, you should first write a level, or rather editor in assembly, and then you should use that. Y and then C. Okay. So we have our position X, Y, C, and then we have our rotation X, Y, Z. Okay. And next we do texture transforms. Let's just Wait a minute. The texture transforms are a bit of a hassle to output. Because there are no ordinary transforms. We could simply add these fields here to a texture transform. Which would be fine, I think. Because we will just calculate the transform matrix from these values anyway. Okay, we'll do that. Even though we don't use them right now. So let's see, texture. Oh, are we actually running into trouble? No, I think the renderer itself, render data structures, object data, texture transform. Whenever we okay, so let's just check texture transform. Yeah, we upload it manually here. Submit transient data. Preferably we should arrange our should be arranged so that we can do total parsing. Do one mem copy for all data. I think it's faster to, on the CPU side, arrange everything in a object data structure and then do one mem copy directly over the PCI lane. All right. See you later, buddy. Yeah, this is an optimization I should do. Even though we could do it right now. Nah, I might change this function in the future anyway. Although, I mean, this is so silly. I think it's faster to just do object data, temp data equals, and then set the temp data world matrix equal to our transform dot matrix here, texture transform to our texture transform, and then our, we should pad it eventually, I think, for performance reasons, but material index, that's the first field, isn't it? Yeah, it is. Material index, which is our material here, and then texture. Okay. Let's see. Temp data, and then simply like this. Um, we could even speed it even more up, I think. Could be added to a local heap allocated buffer where the total data is transferred from vector with a size of game objects. Yeah, I think that would be faster. Or maybe it's faster, I don't know, if the allocation of the vector itself is problematic. I mean, is a CPU-sided allocation faster than continuous write calls over the PCI lane with a whatever latency that adds to our CPU thread? Yeah, I think it would require testing. Reserve space for a CPU-sided allocation before one big mem copy. I'm thinking the buffer itself is created with padding according to the constant buffer layout for DirectX, so it should be fine in terms of the alignment of the data. It should be fine at least. Okay. Do testing in the future of which is faster. CPU side alloc plus one big mem copy or several smaller. Yeah, that makes sense. I would have guessed that as well. But each program is not parallelized. But you can do that in the compute shader. You can do parallelization inside a program. All right, let's see. Right now this will write 0, which means that we would basically get all right. Let's see. We would probably get another yeah, level. And we write our uh, let's do something like that. Texture transform. And then we want some AABBs. Static game objects, that's size. We do AABB indices, and we do the same thing here. Texture transform. Our textures will be loaded wrong as long as we do not have any editing for them, but yeah. It's basically duplication of the transform editing, so I'm not gonna bother too much with that right now. Okay, then file AABBs. AABBs format. And let's do something like this. Okay. AABB equals reference static bounding boxes trans index, although we should change this box index. All right, then we pass out the ABB. And then the last component, center XYZ. We could also split it actually, because file, so it just gets a bit more readable. This should be fine. File. There we go. Next, we want the what do you call it? We want something else at least. We want the half widths. Half widths XYZ. All right. That is basically our saving function for now. Let's see if we. Well, we start parsing that, but oh, we don't add any. That's true. Objects, bounding box here. Okay. Should be fine. Okay. So now we save to file whatever we have created. Let's do some loading then. But first, I promised to implement two functions. Because we will need these, create poll and create player. Otherwise, our physics stuff will crash. So we can't have that. Okay, so here we. Yeah. Let's see, we want this to be moved. Create player and create Paul. There we go. Player Paul texture transforms. And these two functions here needs to be copied. Create player. Okay, dynamic objects. I'm pretty sure this only runs on the player thingy. And this only runs on the Paul. Right now, Paul and the player will be hard-coded into the level editor. Let's see, so we do that. This is for the static volumes. These should be done whenever we create the data. Let's see, object transform. Of course, we need to copy this. Create Paul. Create player. Player model, actual player. This is the Paul. And then we have game objects. Static objects, dynamic objects. Let's see. Mm, let's do a check here. Otherwise, we do 0 here. box. Let's change this. Mm, all right. Okay. So we could also change this to something way better. Yeah, we could actually just, well, now it's maybe a baby, a bit more robust. Okay, let's see. Paul also has a physics object. Well, I think we create them inside the application still. They're not part of this yet. Okay, so we have information there. Let's do some meshes loading, mesh loading. Uh, let's see. Let's do void preload meshes. Let's actually create a different function for that. Preload meshes. Let's see. void create lights. Create lights. Then our create materials. All right, we create some materials. Then if we have this level here, we increase the transform index. Let's see, material lights, Paul. Let's see that size here, because it will get increased. Okay. And then we will do size here. So we create our pole and our thingy there. Let's see if it works if we do create pole, create layer. Let's see, dynamic objects. Let's try commenting this out. M transforms. Let's see. Transforms that size. Otherwise 0. Okay. This should be okay. Object transforms. This should be okay. Also this. And then the static. And the dynamic ones. Let's see. If we successfully refactored all of this, or if we have any problems. We do have some problems here. Oh, we need to, of course, create those first. We should also do those. Let's see. These should be created while we create the meshes. Let's see. Calculate bounding volumes for meshes. Load mesh data. Let's put it in a scope. Okay. Let's see. Everything is pretty weird. It's no problem, buddy. It's no problem, buddy. Okay, so we have something that got messed up. The ordering of things here. Let's see. I think that the floor and the thingy here. Hello, Penguin. How are you doing? Uh, Preload meshes. Okay, let's see. Whenever we step into this function here, we will create all this. Let's see. So our transforms and texture transforms equal to 2, dynamic objects equal to 2, static objects, nothing of the like. So let's see. Our transform index here is 1. Oh, wait a minute. Yeah, we increase it afterwards. So this should probably work the way it used to. Yeah, everything is back to what it used to be. Great stuff, great stuff. How are you doing, Pagan? All right, so we've basically decoupled this old stuff here into separate functions. So now we only create our static objects inside our scope here. Let's put this in a graveyard. Graveyard in region. Okay, so we create our static objects like this. And then we create their transforms. And then we actually do texture mapping here, or rather texture transforms. Okay. Since this might improve our saving, we will do exactly that. Okay. Temp text transform. Let's just do temp tf dot scale x equals 8. Scale y equals 8. And then scale c equals 1. And we will simply copy these values inside the transform itself. And now, whenever we save our level, things will be actually registered correctly. We will also be able to actually edit this inside our editor. Let's see. That's the same. All right. So we got the upgrade of this system right away. Let's see. Oh, whoops. 4 on the X, 4 on the Y, and then C here. And we can just copy this because it's the same. Okay, so everything should look the same. It does, but we have now upgraded our system so that we can uh, save our texture transforms as well. Okay, let's see. Finally, IntelliSense really gets that this is a scope. It hasn't before, which has been bothering me a bit. Okay, so if we load level 0, Um, I can't remember. Is it defaulted to that? No, it should be defaulted. Whenever we load per level ID, it should be defaulted to 0. Okay. I guess we should save our level here. I'm not sure we should use the extension stuff here. Maybe we should just pass in the file name instead. Okay. 1, 2, 3, 4 level. Level. Adds it still. Well. Oh, this is just the parsing. It's not really doing it. Yeah. Oh, did we actually forget to not in the update, not in preload. Parse data the file. The last one is scale XYZ here. Scale XYZ. Okay. Now it would be nice to do a function for testing where we could ask our system to force to load a level. Mm, yeah, that would be pretty fun. Or I don't know if it's gonna be fun, but we could do that. Force load level. Inside our application here, we could do on create level system, and then instead of load level, we could do something like mLevel system. Let's see. Let's do a mLevel system, and of course here return a bool, so that if force load level doesn't return true, we simply return and do not do anything else, and we will not create any more stuff. Let's see, let's just per default return false here and see what happens. We do have a crash. Um, let's set M running. What did we actually call it? Our flag is running. So false and then return. Let's see, post quit message 0. Well, if I remove this, do we get the same problem? We shouldn't. No. So it's related to whatever we do on after on create. Maybe just do on destroy. Do you mean using the Win32 API? Or do you mean just decoding in Windows? I'm unsure what you exactly mean. Do you mean like using Visual Studio and Windows like that, or uh, well, whenever this returns. Oh yeah, yeah, yeah. No, I don't like it very much. I'll have to agree on that. Huh? Uh, this is a window procedure method, yeah. Yeah, it's the same, just one more letter. Okay, so this would actually make us crash. Uh, uh, let's see what happens if we run the program here. Okay, yeah, so we have a crash on our hands otherwise. Yeah, I mean, I would like to actually exit the application. Let's see. M is running, false, and then return. And let's see if M is running. Let's return here. Well, we're still in it. This shouldn't be running. So that's definitely not it. Let's see what's happening here. Okay. Where on earth do we end up if we... Do we end up in run or something? Okay. So where do I get the crash? Also, let's revert back to the... there we go. So let's see, let's get the crash up and running. It's not that. It's just a vector assertion. I'm pretty sure if I turn off the debug mode, we won't have a crash. Whoops, okay. Um, if I just continue spamming the F10 here, it will eventually crash. Do we have a debug assert? I mean, do we even end up in the update step here? Yeah, we do. Okay, this is the crash, of course. Yeah, I knew it. And let's see. Do we still end up in a crash? Okay. Also, well, of course. So if I return up here, I won't be building it. Yeah, it's because I'm rewriting the startup script here, so Let's just tell it to escape, return if this is for temporary disabling on non-loaded level. Let's do if return. There we go. So black screen if we do not load anything. Great stuff. Or else. Okay, so right now we force a level load. If it didn't succeed, we should basically load the standard level here. This should actually be the case, but right now we are trying to set up some forced level loading. So let's do a open file struct here. Please load a delicious level with lots of Pauls in it. There we go. And open, save. Let's see, what's the other macro? Win32. Get open file name. Get open file name. Print. Loaded level. File name. Okay, loaded the level, yes. Okay, so now we force a level load on application boot. We should, of course, load the standard level if we decide not to. This is just for testing purposes. Okay, return true here. And let's flip this. If it didn't return true, we load the basic level here. Okay, so if we cancel, we load the base level. Oh, the simulation itself is not paused. So Paul is gone. Huh. Let's see. I think because of the oh, I might have changed the physics simulation here. There is Paul. So if it takes too long time, I think actually I think this dynamic loading stuff here is not needed anymore. I actually think we deprecated it. Let's see. Yeah. Okay. So let's see in our global settings. This should be Paul because it's not a player. Paul, and this should be player. And let's put offset Paul way up into the air. Okay, and we need to fix this. Read payer, player, not payer, player. Whoops. Let's do create Paul. Okay. Let's see. Do we have any errors in here? We do. Okay. Let's see. Well, he must disappear for some reason. Maybe the delta time itself is too high. Okay, if I really fast, quickly, okay, it's pushing the escape button will also close everything. Okay. Yeah, we will figure that bug out eventually. This should be fine, right? Because if I cancel, everything will still be fine. Uh, if I can, if I cancel and swap to this camera here and do, well, I can't find Paul anywhere. Where did he go? Maybe he doesn't get initialized properly. If we return true, oh, maybe it's because of the return function. No, it's not. It's not. It's not. This shouldn't matter because, I mean, we still build the resources here. I mean, this should even. Yeah, he will know where to get us. I mean, this is the statement that ends up disabling Paul. So, did you notice that Paul was spawning directly inside of us? So the problem is that I've now changed player controller static. Okay, so let's see. When we have our create Paul function here, create Paul. Paul start. Okay. And inside our application, when we build our physics resources here, player character. Well, that's Paul. So this is wrong. The rigid body here is also not the player because the player doesn't have a rigid body. We need a Paul rigid body. There we go. And Paul just jumps uh, straight down from the sky and lands on his feet. Smooth, smooth Paul. Good job. Good job. Okay, so now we should have fixed the issue with Paul not behaving as intended, at least I hope. If we decide not to load a level, well, okay. Paul doesn't appear anyway. Um, what if I'm really fast? I wasn't fast enough. Nope. Okay. Paul just doesn't want to do anything if okay. Let's see. TS is equal to std minimum float TS and 0.5 divided by 1000. This will make sure our delta time never gets too big. Yeah. So we of course should allow for a bigger discrepancy in delta time here. Yeah. So it's because the initial delta time is way too big, so the physics applied to anything is way too big. Okay. Yeah. We could even increase this to something like Visual Studio. Don't you love Visual Studio? I think IntelliSense needs a break. Okay. Let's say that we will never allow any more than 25 milliseconds. Oh, whoops. I should click cancel here. Yeah, I suspect. I think that temporary clamp of delta time to avoid physics weirdness. Let's see, could we even um, now drag the window around without losing Paul? Yeah, we can. Um, so that's also fixing that bug from before. Okay, it's temporary. We will implement something else in the future. We will not select a level here. Great stuff. Man, I should probably clear out the cache files here for Visual Studio. Let's see, how big are they? Not that big though. Okay. Level editor. Saving implemented. Okay. Okay. Force load level. We select our level, and then we should parse our data. First, we should call these functions, or maybe we should just create a const ychar pointer file path. And we will return a bool here. And we will call this function load level file name return false. Fail to load level on false level load. Let's see, load level, do some stuff, then do this. Then do this. Okay. All right. And then we should do some. First, we should check if we can open file. If we ever get to this, we will return true. Otherwise, return false. All right. I'm thinking that probably the level passing here will be the last thing I do today. We will simply just use our OBJ loader logic here. I'll copy most of this. Um, okay. So we will do it C style. File path. C convert to char. Let's see. Okay. F open white char. Yeah, WF open. There we go. Here we go. Great stuff. Couldn't open file. Okay. Let's see. Okay. Let's see, let's call it path. There we go. Let's see. Couldn't open file. It's probably because we open the same the stream. We should basically not create any of this. It's kind of not great. Error couldn't open file. Were we doing it before? Well, does this have anything to do with anything? Couldn't open file, why not? Let's see. Why not? Reload meshes. It just succeeded. Or it didn't? Let's see. Let's move this. Couldn't open file. Does this does it overwrite? Um, I mean, this is weird. This is a bit weird. Let's see, let's close the parse data to file, of course. And then Yeah, I don't know. I don't know. Because it doesn't fail inside the application, I think. I mean, this doesn't make it fail. Nope, that works fine. I mean, why? Maybe... Let me just step into them. File name, testcube.obj. Does it, let's see what's the what the debugging layer gives us. Huh? Uh, um, does it overwrite some state? Okay, let's see if I change the reload meshes here to absolute paths. Let's try that. Well, we're still in that same situation. Is it because I override some value here? Then let's try changing this here. Also, I need to fix the last one here. Okay. Well, does it also happen whenever I simply run the, let's see, release mode version here? So let's see, fonts, levels, models, shaders, texture. Couldn't open. I mean, it might relate to that thing here. I mean, if I simply call this beforehand, I should be fine, right? Or yeah, did it test cube? Huh. Well, it loads most of them. Oh, I'm actually doing something wrong here. Loaded model. Couldn't load model test cube. Huh? Oh, it's because I changed the path. Okay, so this works fine. This procs twice. Now it does load the models. So outside of that scope, okay, what about inside the scope here? We can't we can't load them. Why is that? I'm suspecting that the call to this function here overwrites changes system file path open F. Yeah. Oh, no change yet. So it was actually a bug in the API. I suspected that. Also, let's not do that on the save itself. We don't want to change the directory. Okay, everything works then. Great stuff. Okay, we're back. We're back in business. So now we can get back to file parsing here. We won't be doing that if we can't open the file. Okay. Next we parse it, but nothing's gonna happen. Great stuff. Okay. Let's get the save parse data to file syntax here. There we go. This is the update step. We don't need that. We don't need preload meshes. Parse. We already got that. Okay. In here we will simply take our comments here for the file format. Great stuff. And then we will pass the file. Well, let's open the level and let's move it to the screen. So if string compare line header and the value game object gets found, which means this returns 0. Parsing game objects. Let's do another check here for transform. Parsing transform, and then we will just, what's that screwdriver? Oh my god, IntelliSense! IntelliSense! You're tearing me apart. IntelliSense! You goddamn maniac. Texture transform, and then we have a ABB parsing ABB. File. Let's see. Close file. We actually do that inside our OPJ reader, yeah. Do we have a close? Yeah, std close file. Yeah, it is. It's so horrible. Sometimes I had the whole start of the series totally messed up because of IntelliSense. Might not be 0 terminated. No, might not. But parsing game object, 5 game objects, 5 transforms, 5 textures. Lo and behold, it's correct. Okay. Let me just restart IntelliSense, or rather Visual Studio here. All right, we have our file passing. We know our game object here. Let's see. Parsed file, level file. Okay, so we can scan for values. Inside this, we can create a game object. Whoops, it's not inside the end of file. It's inside here. We don't need to check the matches here. Let's see. We will then scan for our integers. We have our, let's see, ID. ID. So ID, mesh, material, texture, transform, bounding box, bounding sphere, and then flags. Okay, the last one shouldn't be set. So obj ID, and then mesh, and then material, and then texture, and then transform here. Oops. Bounding box. Bounding sphere. And then flags. I'm not sure what you mean. Signed int. let's see. It doesn't change color. I think, at least not in my end here. Static game objects. And place back std move the object here. No, me neither. So and then let's enter debug mode here and see if everything gets set correctly. If we select the level here, let's see, game objects, static game objects 5. ID 1234. Does that correspond to our level? It does. Does this it does seem right. Yeah, it does seem right. Let's check the last one here. 413164 -1 and then the flag of 1. Yeah, okay, so that works perfectly. Next we will process the hello Rengoku, how are you doing? Object transform. It's pretty good. I'm almost done with the basic level editor here today. So that's pretty great. I've been working on this project for how long has it been? Well, maybe a month or so, maybe a bit more, depending on where you draw the line between the UI work and this. Okay, let's see the transform here. So let's see TF, position X, Y, and C. 1, 2, 3, and then TF, rotation X, Y, and C. 1, 2, 3. And then scale X, Y, and C. All right, so this should store our transforms here, and place back our, and move this one here. But we also need to compute a matrix according to our values here. So since we already do it in the update step, um, let's just find that part of the code. Okay, blah, blah, blah. So we calculate scale, rotation, and stuff like that right here. Not save level, we don't need that. We need, are we working down here? No, that's the parse file. This is the preload meshes. This is the, did I close it? Maybe I did. Yeah, I did. Or what? No? Yeah, it did. Oh, wow. I must be getting tired. All right. The scale will be our transform data. The rotation will be our transform data here. And lastly, our translation will be based on our position. And then our TF dot matrix will be equal to scale, rotation, translation. There we go. Okay. Let's check if that works. Let's load this level. Okay, we have a problem somewhere. Okay, let's see. Uh, uh, reload the stuff here. Oh, we might have discrepancies here. Or do we? Let's see, low level, no, that should be the same, but yeah, have we saved the correct ones? I'm not sure. How many times does this? Let's see, right now our transforms has a size of 2, now it will have a size of 3. And let's check our level data. Okay. Let's see, material, no, mesh, material, texture, then transform. Okay. Let's see, so where is the problem? Add static objects. Let's see. Oh, maybe. Oh, yeah, we don't add the texture transforms. That's why. So, this should basically be the same. Texture transform. And instead of this, it should be the transform. Yeah, this should be the same. What problem do we have right here? Ah, of course. Okay, there we go. We have just loaded a level from file. We only need our AABBs. And then we're done with this loading system here. Great stuff, great stuff. Texture transform gone. Okay, so lastly, we don't need this matrix stuff anymore. We only need our AABB here. We don't need this anymore. All right. Bounding AABB. AABB. Let's see. We have 6. The That's a pretty broad question. Could you be more specific? What are you actually contemplating? Why? See. X, Y, and C. Let's see. Okay, we will do 6 values here. Uh, to a new shader, as in a whole other pipeline, or just a different entry in the root signature, or I'm still not sure what you mean, because there are a lot of different issues in terms of the descriptor management. Existing shader. Okay. Uh, I'm expecting that you have it bound in the HLSL code, right? If not, let me know. But I have a tutorial series on YouTube in terms of DirectX12, where we do a toon shader and some different resource binding. Feel free to watch that if you are in doubt. But um, during my polygon draw calls, I bind my descriptor tables to my root signature for my textures and for my, I think it's materials. And then I individually bind a constant buffer view for each specific object that I want to draw, since it has a buffer of per object data, as I call them. And they are allocated in GPU memory on a page system that just spits out allocation indices. So, but of course your root signature has to be set up uh, to be able to kind of like slot these input elements in. This is just an abstraction. It's basically calling the underlying graphics command list. So don't worry about that, as you can see here. Yeah, I mean, I've created a page-based allocator for each memory address, which handles stale and no, I haven't found the need for anything that dynamic. It'll just slow everything down anyway. But you could have abstracted behind some method. I mean, you could. I've done systems where I abstract all of this away, and I simply have some kind of like draw call buffer which stores exactly what's going on under the hood. I've also had a descriptor heap allocator system that just spits out descriptors for objects, and then does garbage collection whenever the object isn't referenced anymore. Um, you could do stuff like that, but it depends on what you're actually trying to do. I mean, I usually refactor my renderer and my setup whenever I have the overall structure for it. So this is the second iteration of this renderer, and it will change again. And if I decide to do multi-threading, where all the draw calls are dispatched to different threads on the CPU side, I'll refactor it again, and of course implement in other systems. So um, Are there any reasons why you would like another system? Because it might be perfectly fine to do some dynamic stuff. I think DirectX TK does it very dynamic, and I saw an engine that actually did some kind of very abstracted root signature and pipeline generation, where you simply just kind of like specified which data types or um, yeah, tables of data you needed to bind. Yeah, it is. But you could um, set up a sort of quote unquote gateway to your descriptors, meaning that you would have a allocator or page system, a I think DirectX TK calls them graphics resources, which are just um, uh, buffers and descriptors that get allocated on the fly. And this system has a backend where you can just ask for a resource and it will allocate it for you. And then you could tell it to release that resource, meaning that it's no longer needed, but it wouldn't deallocate the not necessarily deallocate the underlying resources if it wasn't needed, but keep them in cycle for future use. It's it's always faster to reuse something than to do an allocation. So, but under the hood, you need to bind your draw calls and your shader bindings manually somewhere at least. Okay. I hope it was helpful. If not, and if you disagree, let me know. I'm by no means an expert. Okay. Let's see here. Does our level loading work? No, not entirely. As expected, at least. Uh, okay. Yeah. Be mindful that this engine has only been in development for some months, and yeah, it's not very sophisticated, but it gets the job done. Once I get more complex draw calls, I'll do probably multi-threading, and then it's yeah, probably gonna get yeah a bit more sophisticated. Okay, let's step into this function here and see what values we actually get. Mm, I'm just gonna compare to this. Then the half width here, 20, 20, 20. Let me see. Does our static game object here, bounding box 4. Uh, uh, uh. I'm pretty sure this should be 0 because we don't want the translation, we only want rotation. I'm pretty sure. Okay. Let's see if we actually get any bounding volumes drawn. Whoops, that's the wrong button. Now let's enter. Okay, so yeah, these are not transformed, of course. So there's some problem in terms of storing them, I think. Paul is hanging out on top of this bounding box here. But yeah. So let's see. If we decide not to load a level, whoops, I shouldn't press escape. I should press cancel here. But we decide to save the level. Does our bounding volumes here change? Nope. It doesn't seem like it. Ah, now that's curious. Am I doing something wrong here? That's really curious. Let's see, when I create the level here, bounding volumes, transform index does get bound. But do we even use it? Do we even use it anywhere? I mean, the bounding volumes themselves. Position, scale, I mean, that is so weird. There's some bug somewhere. let's see the second AABB here. 0, 0. Okay, it does get preloaded like that, and then huh. I mean, that's so weird. If I disable this, will I get into trouble then? No, everything will load fine, so we're not using this. But for some reason, why? I'm probably storing the information in some weird way. Am I not? They are even corresponding. They are directly corresponding to the but why is it 20? I think it's the writing, it's the save level thing here. I'm think the data is kind of corrupt. Okay. Isn't it? It's not, or what? AABB indices. I mean, 20 times 20. Well, it's not supposed to be. Well, I mean, I mean, random visuals, AABBs. The positions directly correspond to the values. Okay, let's try stepping into the parsing here whenever. Let me try to save the file here. And then inside our dynamic or static bounding box is AABB. Let's see, center, half width. Yeah, that's this does contain different values. Oh, I just saw it. I just saw it. Me too. Thank you for dropping by. Have a nice day. As you might have seen as well, we are not actually parsing out any information here. So we need to resave our file. Whoops. We should of course not load that file. We should save it instead. Here we go. And then we can load our file and everything will be fine. All right, great stuff, great stuff, great stuff. We have loading and saving. The last thing we need to do is to on create here, delete objects. Let's see, unsigned int transform index the object dot transform unsigned int texture tf index. That's the same as transform actually, transform index, and then we will bounding box index will be p object bounding box. Let's see, transforms. M transform texture transforms. And then static ABBs erase. Let's see, whoops. Bounding box index here. So we delete that. Transforms, static bounding box. Here we go. Okay. But also when we add it, we add the texture transform. We want the temp object here, bounding box to be static bounding box size, and then create a transform. Let's see, bounding AABB, temp AABB. Equals M base bounding boxes mesh ID here. And then static basic base bounding box here. Temp ABB. Okay, I think this should be it. Let's see. Let's cancel this. Let's enter little level editor mode. We can now add some values here. Minus doesn't work for some reason. Well, I need to fix that. Let's set it to texture number 4, I guess. And then scale it on the C axis here. No, not on the C. on the x-axis. And let's see, we create a bounding volume for that one, which is great. Let's try saving this. Let's see. Save level, and then let's close it, and then let's open it. We do get a problem here. For some reason, let's see. Let's update our level file. Let's see. Look at the data here. There are 6, 6, 6. Huh. I wonder where our problem stems from. Okay, let's see. Okay, it's not inside that system. It's maybe inside this. Huh. Hmm. I know why now. It's because the collision detection algorithm here actually uses the transform index. Yeah, so we will need to fix that. So if I add the static object and move it upwards, and if I save the level, I shouldn't be having any trouble, but I'm not certain. Yeah, if they were ever to collide, we would have a problem. Okay. Save. Bug fixes. Let's see. Physics uses transform index for collider for static colliders. All right. Minus, let's see. It might not be the same key here. No, that's why. It doesn't register virtual key. Subtract. OEM. Minus virtual key Win32. Minus is it the same? No. Minus key Q pointer I equals this. Okay. Wow, that's definitely not correct. Oh, whoops. There we go. Whoops. Okay, this should be fine. If you really want to mess with someone, just mix up the keyboard input stuff. Okay, minus 10. All right, great stuff. Great stuff. We have a level editor that allows us to add objects. Let's see. Mesh 1, 2. That's a big mesh we're inside. 3. It's a bullet. Okay. Let's see. Let's change the texture, the material here, so that we can see whenever we deselect it. And then the texture here. Ah, okay. Maybe I have an idea for the the selection system. Maybe we just change the material instead. Do it something to something with only diffuse color and yeah. Maybe we do that instead. Maybe that's cheaper. Although it would be fun to compute like a merged texture on the compute shader. It would be a fun project. Maybe we should do that. Okay, but anyway, let's see. 5 doesn't exist. Okay, great stuff. So we load our level here. Let's move this 10 and then save the level. Okay, great stuff. The level editor is now officially done, at least the first version of it. It does have a small bug, but that's not related to the level system itself. It's related to the physics system. We do have a bug for that. Let's see if our player controller here actually collides with our new object. So let's see. We should be colliding here. Yeah, I can't move through it. That's great. That's pretty great. All right, that's awesome, man. I've been working so long for this. First on the UI, then on a bit of rework of the whole application layer. As you might recall, everything was stored in the application layer and now it's way more clean. Right now we force a level load if we want to use a level, otherwise we just load the base level itself. We clamp the delta time due to problematic delta time scaling. All right. Next, our plan here says that we should start a design document with world scale information, and we should probably redo a lot of the models so that we can build a level. Oh man, this is great. Then we will start a design document, fix up models for level editing, add clear out stale materials, add nice textures, maybe build a level, and then shadow mapping. Then we will do shadow mapping. Great stuff. All right. Are any of you guys still alive here on the channel / stream? Well, it doesn't seem so much like it. All right. Anyway, I've been going at it all day. I think I've achieved most of the goals today. Yeah, we still haven't implemented texture editing in terms of texture scaling and so forth, but that will be an easy implementation since it's just more of the same. So yeah, we won't be doing that. Um, at least since I've been streaming almost 7.5 hours today, and before that I also did some work on researching how to do a gizmo uh, for dragging around objects, rotating objects inside the viewport of the editor itself. So yeah, that's basically 8 hours of work, or even more. Uh, yeah, and I also have to go to work tomorrow, and I would like to go to the gym today. So yeah, there's definitely not going to be any more work from my side today on this project. Maybe I'll do a short video on some sort of channel update, um, since it's been a couple of months almost since I've done that. I could also wait till the end of the month and do a video update, but yeah, well, I'll consider that anyway. Um, yeah, but I'll definitely be having some sort of break for the day, not do any more work on all this. Yeah, yeah, I feel really good that we finally achieved the end goal of having a level editor. As you can see here, I added this object here to the level before, and well, yeah, Yeah, I would definitely like to see what impacts the CPU time the most anyway. I guess you could always look into that. Anyway, I've been talking about it for several times now. I'll be ending the stream shortly. Thanks to everyone who dropped by, interacted, and made this an enjoyable experience. If you find any of this content helpful, feel free to comment, like, or subscribe. Or support the channel in any way you see fit. Um, yeah, I hope I see you around the channel in the future. Take care, everyone, and keep on trucking. Bye bye.